same thing here. We're gonna multiply the top. So like 1 times 4, that's 4. X to the 10th times x to the 4th, that's x to the 14th. Y to the 8th times y to the 5th is y to the 13th. We're just adding the exponents. On the bottom, it's 2 times 10, it's 20. X to the 8th times x cubed, that's x to the 11th. Y to the 6th times y to the 5th is also y to the 11th. Okay, so next thing here is to cancel or divide. Actually, we were doing that the other way. So to do this, 4 divided by 20 is 5, but the 5 actually goes on the bottom because 20 is bigger.
You mean 1 over 5.
And then x to the 14th, x to the 11th, you're subtracting, so that's x cubed.
And then y squared.
And then y squared, yeah. So just looking at the answers, I guess that's the only one that
Yes, it is.
makes sense here.
Yeah, it does. Okay, now I'll share my screen for the next one.
Okay, so we're up to 19 now.
Mm-hmm.
Okay. All right, so I'll share my screen. This problem is kind of similar to ones we were doing earlier. The difference is that you have to factor potentially 4 positions: top left, top right, and bottom left. So for each one, it could be a different kind of factoring. So when you look at 5x plus 5x squared, because both of them have a number and a letter or variable that are the same, this is a GCF factoring. So the number is minus 5x, because x to the 1 is smaller than x squared. That's what you're going to factor out of both. And I mentioned this before, like when you're doing this, what you're actually doing is you're dividing both of these by minus 5x minus 5x. So the one on the left here is actually 1, because they're exactly the same. On the right, 5 divided by negative 5 is negative 1, and then x squared divided by x is just x. Is that okay?
Yes.
Okay, and that unfortunately, that means that's just 1/4 of this problem. So I'm going to go ahead and write it back over here, minus 5x, 1 minus x. So just move this up. So the next one we'll do here, we'll go bottom left here. X squared minus 7x plus 6. What you're looking for are 2 numbers that multiply to 6 but add up to negative 7. And the negative there is key, because that tells you that it's negative 1 and negative 6, meaning they both have to be negative. The only way you can add up to a negative number is if they're both negative. And then another option is negative 2 and negative 3. Do either of these, and this is the question you're asking yourself rhetorically, is do either of these add up to negative 7? And you say yes, it's the first one's there, x minus 1, x minus 6. And that's what goes down here on the bottom, x minus 1, x minus 6. Now we'll move top right, x squared minus 2x minus 24. And you're looking at minus 24 now. It takes the sign. And you want to find 2 numbers that multiply to minus 24 but add up to minus 2. So this list is quite a bit longer. It's -1 times 24, but it's also 1 and -24.
Mhm.
So yeah, they're both here, like they're the same, but the sign is a different place. And then there's -2 and 12, 2 and -12. And this list actually goes on for a while here. -3 and 8, 3 and -8, -4 and 6, -4 and 6.
I'm going to go with.
So we're looking for the one that adds up to -2.
Probably 4 and -6.
Yeah, I'm at this one. So it's x plus 4, x minus 6. Okay, and the reason we need that is we're going to rewrite the top right, and then the bottom right stays the same. So all that work we did like simplifies the problem to what I'm going to show you here. Now the next part is by comparison very easy. You just cancel things that are the same. So do you see how there's an x minus 6 here on the top and the bottom?
Mm-hmm.
Those cancel. 5x cancels with 5x. So let me write what we're left over with. -1 minus x, x plus 4, x minus 1. Now, maybe it looks like this to you. It should look like these are kind of the same, the 1 minus x and the x minus 1.
Mm-hmm.
They are when you distribute this negative in. So when you distribute this negative into both, it becomes -1 plus x. We're just talking about the top here. But then you switch the order and it becomes x minus 1. And then on the bottom there, you still have the x minus 1. And then this x plus 4. And that's where you can see that these all cancel.
Okay. So then it would be x. The answer would be x plus 4.
That's it. That's the only thing left over.
Oh my gosh, that's like too much work.
It is. These are the absolute longest problems. The only thing longer than this is when you add or subtract instead of multiplying here.
Oh my gosh. Okay. So it'd be x plus 4, x does not equal 0, x does not equal 1, and x does not equal 6.
That looks right to me.
Okay.
I think it was the only one that had that answer, though. I mean, just double check. There's only one that said x plus 4. The other one was x minus 4, I believe.
Yeah.
All right.
Is this the same one?
Go ahead and share your screen. I'll take a look.
Oh, yeah.
It's likely very similar.
I thought I was sharing my screen for some reason.
I've made that mistake so many times. Yeah, this one is just like that. Let's go to the let me look at 21 here. Can you scroll down to 21, please?
Yeah.
Let's just see if these are the same, kind of the same. Yep, 22. Keep going. Keep going. Yeah. Okay. So there's good news, bad news. And so if we work through these together, we can definitely get all this done for sure, and probably something else. But they're very slow. Alternatively, we could do something else if you think that would be more useful. Remember, this is your time, and I don't want to. I'm not going to dictate how we use the time. So, do you want us to continue with this, or do you want us to move on to something else?
Let me see, because I know I have 7.3 to do.
So this is somewhat like a building block to what we're doing in that other tab. Meaning, like you in some ways know how to do this because we've done some problems like it. But we can obviously do them together if you would like.
Okay. I don't know. My quiz is tomorrow, but these assignments are still open until like whenever the test is, I want to say.
Okay. So that's a good reason to save them for later.
Yeah, let's just save those for later. Let's just do this.
Okay, so let's go back to 20 or wherever we left off.
Okay.
All right, so let me. All right, so it says find the product, same situation as before. Let's look at this one on the top left, 3x squared. 3x squared minus 6x. This is a GCF because they both have an x and they both have a number. So the greatest common factor is 3x. So you divide each of these by 3x. Can you tell me what goes in either position here? Either 6x divided by 3x, whatever that is, or 3x squared divided by 3x?
It'd be 1 and -2.
So
I mean,
right here, 1x, there's an x, because there's two x's that go with, because it's x times x over x, and the threes cancel.
Okay.
Okay, so that's our top left.
And it would just be 2 because the x's would cancel out.
Yes, exactly. So now we're going to look at x squared minus x minus 2. And this is that a equals 1 factoring where you look at the last number here and you look for two numbers that multiply to -2 but add up to -1. So it's either 1 and -2 or -1 and 2.
Mm-hmm.
Do either of these add up to -1?
No.
That one looks like, to me, it looks like 1 plus -2 gives me -1. That's what I'm asking.
Yeah.
So this is x plus 1, x minus 2. So that goes in this position here. Okay, the bottom right is actually going to stay the same, but this top one is the last like little. It's another a equals 1. It's another factoring where the leading term is 1. That's what that refers to. So you look at the very last number, the constant, and you find all the pairs. So 1 and -7, -1 and 7, and you ask yourself, do any of these add up horizontally? Do any of them add up to this -6?
Yeah, 1 and -7.
Right. So this becomes x plus 1, x minus 7. I just use the one that works and rewrite it here. So now going back, top right, x plus 1, x minus 7. And now the part that most students like, it's the canceling. So x minus 2 cancels with x minus 2, x plus 1 cancels with x plus 1. There's an x here and there's an x squared here. So this 1x cancels with this exponent. And so the last step is to rewrite what's left over. There's a 3 that's left over. There's an x minus 7 that's left over. And a 14x that's left over.
Okay.
And it probably is like an x does not equal -1, x does not equal 2, because those are the two that we canceled.
Yes. So it'd be the last one.
Sure. If you want to share your screen, I can look, but I'm sure it's probably the only one that really matches.
Yeah.
All right, 20, yeah, 20 looks good. All right, so find the quotient here, find the quotient. So let me share my screen. Okay, so many years ago, you had an instructor that would say, what is 4 divided by 3/4.
Mm.
And you would say, oh, it's 4 times 3/4. You knew to change this division into multiplication, and then you switched reciprocal or flip. You knew to flip those. So the same principle applies here. This problem is really minus 3x over x squared minus 6x plus 8 times, and then you just flip this. So the x squared minus 11x plus 18, 27x minus 3x squared. You see how they switch positions? We just moved what was on the bottom to the top and the top to the bottom.
Right.
So now it's actually just like a problem that we just did. It's no different. You have to factor potentially all 4 positions. So we'll start with the bottom left here. X squared minus 6x plus 8. So we're looking for 2 numbers that multiply to 8 but add up to -6. Since it's -6, they have to both be negative. Which pair works here? Which of these adds up to -6?
Would it be?
So -2 plus -4,
yeah.
they're both
They're
negatives. So it's like I owe my friend $2, I owe my friend $4, now I owe them $6. So we got x minus 2, x minus 4, and that's this bottom left position. X minus 2, x minus 4. Now we also need to do this x squared minus 11x plus 18. And it's the same type. It's that type where you have to look at that last number, 18. And because this middle number is negative, these are both negative. Do any of these add up to -11? That's what you're asking yourself after you write them all out. Do any of these add up to -11?
2 and 9.
So we go x minus 2, x minus 9. The sign is important in this. Okay. So then the very last type of factoring here, notice that there's only 2 terms. They both have an x in it. They both have a number. It's a GCF factoring. And I'll tell you the GCF, it's 3x. But you now divide each term by 3x. So this first position, 27 divided by 3 is 9. X divided by x goes away. In the second position, hopefully you can see that 3 divided by 3 is 1. X squared divided by x is x. Is that okay? Is that all clear?
Yes.
Okay. So it's kind of like there's all this scratch work on the right, and then the actual problem flow is on the left. So now the part that we like is canceling. So this x minus 2 cancels with that one. Okay. 3x cancels with 3x. Okay. And here's what's left over. Negative x minus 9, x minus 4 over 9 minus x. And then from a previous problem, do you see that x minus 9 and 9 minus x are the same except for the negative.
Mm-hmm.
You remember that? Like to flip one, you have to put that negative in there. So the
Right.
top becomes negative x plus 9, which if you rewrite, it becomes 9 minus x. On the bottom, you have x minus 4, 9 minus x. And from there, these cancel, but there's a 1 left over in the top. So your final answer is 1 over x minus 4.
Okay. I'll share my screen. Okay. And there's not like an easier way to do these?
Well, there's certainly plenty of online options, but the by hand is the only way.
Is Desmos part of the online options?
That's an interesting question because I think it would work. Let's try it for this one. So you would need to literally type in exactly what is written there in Desmos, and that's where I'm not sure if you'll be able to do it. But go ahead and do it. I didn't see it, but it's 2x minus 4. And then it's going to say divide. So the way this will work in Desmos is if you hit divide there, and see, this is where I don't necessarily like. Could you I'm sorry, I'm losing my words. Select everything that's in there, and then put a parentheses around it. You can just put a left parentheses. It'll do it automatically. There you go. Okay, now go into the right and divide. And then even though this looks different, this is the same as what is there. X squared minus, so go ahead down to the bottom there, x squared minus 6x. Or maybe put a slash first. Back where the parentheses are. Yep, right there. So x squared. Okay, so let's go back here and go back to your other tab. And you want to double, triple check that you got it the same. I think you do. So now, and this isn't the best example of this, but go back to your Desmos and go to the next line and type y equals the first answer, which I think is minus 3/2. Okay, do you see how those lines are the same?
Yeah.
So there's your answer. Now, the problem is if you go back to the other tab that just gets you down to 2 answers. But in a previous problem, it might have given it to you perfectly.
Right.
Okay. So how do we decide now which one it is? Because they're really similar. So the answer is to do it the way that we had been working through. So yes and no. Now, if you go back to the previous problem, if you scroll up, I'll try to explain how you can decide. Your answer just moves. Just be careful none of the other ones did. So go up to that one here. So see how this one excluded 0, 2, and 9. And actually, this is not a good example of this. What I was going to say is that it's there's always going to be an exclusion, and it really comes down to how many there are. How do I want to get you to? Because I don't want you to guess, but there's some risk here in doing it this way. So you scroll down to 22. That previous one didn't help here. So it's either A or B. The only difference between A or B is that in A, the answer could be 0, and B, the answer could not be 0. Since you canceled all your X terms, that's why it would be B. Because there's no X terms left. And I can't really give you a better explanation than that without working through it. Let's look at the next one. Maybe we can use the same approach for it. Okay. This one you cannot, but you can for 24. So 24, but you like 23. You said that wasn't too bad.
Oh yeah, it's just like the multiplying and stuff.
Yeah.
Right?
So go ahead and try 24 here. In Desmos. Scroll down here. Let's see what the answers look like. Okay. Well, so here's your potential problem. Good. Can you go back to that one? So you're going to have to type in everything in there in the question, the prompt there, but then you're going to have to type into the second line each of those 4 until you find the one that matches. Now they're only different by a sign. So it will work. It will work. So what I suggest, here's my suggestion, is you do 24 on your own at some point, see if you like it. We do 23 together, and then we move on to something else with the rest of the time.
Okay, that sounds fine.
Okay. Okay, so let's find the quotient. I will share my screen. Sharing screen. There it is. Okay. Similarly to the previous problems, you have to, because it's division, you have to change it to multiplication by the reciprocal, which means you only change the second one here. So what's on the bottom goes to the top. What's on the top goes to the bottom. Okay. So now the top, we have a 1 and a 5. That's 5. X to the 9th, X to the 8th. So that's X to the 17th. I didn't write this down. It was Y to the 5th, Y to the 4th. So that's Y to the 9th. Z to the 5th. And then there's no other Z's. So there's that. The bottom, 4 times 1. That's 4. X to the 1, when it's not written, it's 1 times X to the 7th. That's X to the 8th. Okay. And then Y to the 9th times Y to the 9th. That's Y to the 18th. And then last one here is Z to the 9th, Z to the 9th. That's Z to the 18th. So as I mentioned before, it's really like you break these up. You've got a 5 on top and a 4 on the bottom. Notice that immediately tells you it's this last answer, but let's just confirm it. X, because it's the only one where there's a 5 on top and a 4 on the bottom. X to the 17th over X to the 8th, that's X to the 9th. Y to the 9th, Y to the 18th, that's Y to the minus 9. Z to the 5th, Z to the 18th is Z to the minus 13. Okay. And then if you recall, if the exponent is negative, you move it to the bottom. Y to the 9th, Z to the 13th. There.
Now we can just start on this one.
Sounds good.
How do I start it?
I'm waiting on you to share your screen.
Oh, I'm not sharing. My
No,
bad.
it's okay.
Keep forgetting that. Okay. Here we go.
All right. So you do know how to do this problem, but I'll definitely work it out for you so you can see. Maybe the next one will be like it. In the numerator, I'm going to snip it in my screen. Both terms have a GCF in it. Let me get to where I'm sharing my screen again. What you're looking for with GCF, and that's what this is on the top, both terms have to have a number or a letter. In this case, it's x that's the same. So you look for the smaller exponent. What's the smaller exponent?
2.
2. So you got 7x cubed minus x squared here, and then you're dividing both of these by x squared. So this becomes 7x minus 1. You can see that. And the bottom is 2x cubed. I think I used blue when we did this right here and this right here, x times x, x times x times x. You can see there was a bunch of cancellations. These canceled, but there was an x left over on the bottom. So that resulted in there being an x on the bottom, but on the top, it was 7x minus 1. On the bottom, just the 2x.
So it'd be 7x minus 1 over 2x?
Yes.
Okay.
Whenever you're ready, go ahead and share your screen again. We'll see what's next.
Okay. Bye, Grandma. Love you.
Love you too.
Alright.
All right, so this is good. This is another one like what we've been doing. So that'll make it really really good because it's just another repetition. So let me share my screen. And if you ever need to break away from the lesson, either just mute me or tell me you're going to leave for however long, and I'll obviously wait until you're ready again. So we'll look at the top one here, and it's that problem where this is 1 in front, so you go to that minus 18, and we're trying to find two numbers that multiply to minus 18. So like minus 1 and 18, or 1 and minus 18, but they have to add up to -3, so they gotta be fairly close together. It's like -2 and 9, 2 and minus 9, -3 and 6, 3 and -6. So if you notice there that the only one that works, this one right here. So the top, x plus 3, x minus 6. And the bottom's kind of the same deal. It's x squared minus 7x plus 6. You're looking for two numbers that multiplies to 6, but add up to -7. So -1 and -6, or -2 and -3. Do either of those work? It has to add up to -7.
-1 and -6.
Good. So that becomes x minus 1, x minus 6, x minus 1, x minus 6. These cancel. Okay. So what goes in this first box here is what's left over here. That's what goes in the box there. What goes in this box on the right is from the canceled terms. If you remember, we have to do this first by adding 6 to both sides, so x does not equal 6. And we did a bunch of problems like this. So hopefully this just looks like something we've already done.
Yeah. This looks pretty easy. Not too bad, at least. Okay.
All right, so it looks like, oops, I got my wrong screen pulled up. Okay. So this one's really similar, really similar. It might even be some of the same numbers we've already done. Let me grab a snipping tool. So one of the reasons Desmos worked is because you had multiple choice answers. We didn't have them. For this, we don't have them. So there's no shortcut other than to do it the way that we're doing now.
Mhm.
So you first start with that x squared plus 36, x squared plus 13x. So the first thing you do is you look at this 36. Actually, I didn't need to write all that. I'm sorry. Is the 36, and you're looking for two numbers that multiply to 36 but add up to 13. Okay, 3 and 12, 4 and 9, 6 and 6. Do any of these add up to?
4, 9.
Yes. So that becomes x plus 4, x plus 9. So what I usually show students, I think it's an appropriate time to do it now, is rather than rewriting this, I actually just write it on the top like this. That way I don't have to keep writing these things out. Now I know you're probably all digital, but if you were pencil and paper, you'd be surprised how long this takes to write out all these problems.
Yeah. Takes a while.
Okay, so now we're looking at 10, and we want to get to -7. So whenever there's a negative that we need, it's both negatives. -1, -10, -2, and -5. Do either of these add up to -7?
-2 and -5.
Yes. So this becomes x minus 2, x minus 5. And again, like instead of rewriting the whole thing, I'm just going to write this. And this is the first unusual situation because you're used to canceling, but there's nothing to cancel.
Right.
So you just write, and I don't know if it would have accepted this. So that probably will be accepted. Not sure about your system though. We can take a look.
Yeah, x was 4, x over 9. Okay, now I got it.
Fantastic.
Okay.
All right. right, so this problem, slightly different, but it is doable. Let me snip it in. Share my screen. All right, so the I'm gonna quickly do the numerator here because we've done enough of these that I think you understand. Now the bottom is what's called sum of cubes.
Mhm.
And there's formulas, a cubed plus b cubed. If you don't know the formula, you just can't do this problem, but it becomes a plus b, a squared minus ab plus b squared. And I put this in the category of like, you probably don't ever need to know this except for this problem, but because we didn't see it on the quiz. Now, if you take more math, you might see it again, but we've talked about that probably isn't going to happen. So it looks like this: x squared minus 2x plus 4. And then you see that the x plus 2's cancels. So what's left, what goes in this box is the x plus 9 divided by the x squared minus 2x plus 4. And then what goes here is you set x plus 2 equal to 0, not equal to 0. Subtract 2 from both sides. X does not equal negative 2.
Okay. So it was. Oh my gosh. Okay. Now I'm on to this one.
All right, hey Jayla, so sorry about that. I was muted for a moment. Is the back and forth working for you, or is it at all distracting? The fact that you share your screen and I share my screen, and
No, yeah, it's good for me. I'm cool.
Okay? It's good to hear. So the top one here, you're trying to find two numbers that multiply to 12 but add up to negative 7. Because it's negative, they both need to be negative this time.
Okay.
And these are the possible pairs. Do any of these add up to negative 7? Well, the last one does. So this is x minus 3, x minus 4. The bottom one here is what's called difference of cubes.
Mm-hmm.
And sparing you a long justification, it is just this. It actually looks really similar to the previous formula, but for our purposes, we're just going to use it. What number cubed gets you to 27, though? What number times itself gets you to 27?
3.
3. So the bottom is really x cubed minus 3 cubed. And that means that your A is X and your B is 3. So notice I just substitute the numbers in here. A is really X, that's X squared. A times B is 3X. And then 3 squared is 9. This takes the bottom position, X minus 3, X squared plus 3X plus 9. These cancel. So what's in the box here goes in the numerator. What's in the box here goes into the denominator. And again, you set the part that you cancel. That's for the second box here. You set it not equal to 0 and you solve for X. You add 3 to both sides. So X cannot equal 3. So again, to summarize, you got to get this X minus 4 in the top, X squared plus 3X plus 9 in the bottom, and then 3 goes here in the not equal.
Got it. Okay.
We might have time for one more question, depending on the length, complexity, all that stuff. Let's go past this one. This one will take too long. Let's see if there's, yeah, let's do that. We'll do 7 looks good, that previous one there. Because it's actually just a flip of, I think, question 1 or one of the first ones that we did in this group. But let me snip it in here and then I'll share my screen. I'm also kind of curious, you very few students, but we've done it twice now, do 2 hours back to back. I mean, I'm glad you did it. I think you got a lot out of it, but you probably all mathed out for the day.
Yeah, most definitely.
Okay, so notice on the bottom here, there is an X in both terms. So your GCF is the X, and then you divide each of these by X. Okay, so the way that works here is it's 3X minus 4. So you have 2X squared up top over X times 3X minus 4. And then one of the X's on the top cancels with one of the X's on the bottom. That one cancels with that one. So your final answer is 2X, or I'm trying to grab the right color, 2X over 3X minus 4. That goes into this first box. And then you set the thing that cancels equal to 0. So that equals 0 there.
Awesome.
Great. So thanks so much for scheduling. Be happy to help you again whenever that is. I'll send you the notes here and a link to the screen recording, and I hope you have a great day.
All right. Awesome. Thank you. Have a good one.
You too. Bye now.